Hey there, and welcome. Today, we are going to crack the code on one of SQL's most powerful and, let's be honest, sometimes intimidating tools, window functions. If you've ever hit a wall trying to do complex analysis without squashing all your data down, then you are in the right place. All right, let's just dive right in with a classic data problem. How many times have you been asked something like this? Find the top 2 highest paid employees in each department. Sounds pretty simple, doesn't it? But if you've ever tried to solve this with just basic SQL, you know it's surprisingly tough. So your first thought might be, I'll just use group by. And, for finding the single highest salary, that works. But here's the catch. Group by squishes all your individual employee rows into just one row per department. You get the max salary, sure, but you lose the names, the employee IDs, all of the details. So it just can't answer our question. But this mystery function on the right, it can, because it keeps all our original data perfectly intact. And that mystery function is, of course, a window function. Basically, it's a special kind of function that performs a calculation across a window of related rows. And the best part? It does this without collapsing them all down. It preserves every single row. You'll always spot them because they have that over clause right after them. So if you remember just one thing, let it be this. Group by aggregates and reduces your rows. A window function, on the other hand, calculates something and then just adds it as a new column, leaving all your original rows exactly as they were. That difference is everything. Okay, let's get our hands dirty and start with what is probably the most common use for window functions, ranking stuff. First up is row number. Think of this as your most basic, straightforward ranking tool. It does exactly what it says. It gives every single row a unique number in sequence. 1, 2, 3, 4. No ties, no gaps. It's perfect for a simple leaderboard. Now, where things get really interesting is when you have ties in your data. Row number will just give them different numbers anyway, but rank and dense rank are built to handle ties. The key difference, and you can see it here, is how they handle the number after a tie. Rank will leave a gap in the numbers, while dense rank keeps the sequence, well, dense. No gaps. And this table here shows what that looks like when there are no ties. Everyone just gets a unique number. But let's imagine for a second that Rahul also made 60,000, just like Amit. Rank would give them both rank number 1, but then it would skip a number, so Robbie would get rank 3. Dense rank, on the other hand, would also give them both rank 1, but Robbie would get rank 2. It's a subtle but super important difference. All right, ranking is cool, but now we're going to get to the clause that actually solves our original problem. This is where it gets really powerful. This right here is the secret sauce, partition by. I love this little phrase for it. It lets you group without grouping. What it does is slice your data into these little subgroups or partitions, and then the window function starts over and runs independently inside each one. And would you look at that? Here's the result. By adding partition by depth, our ranking function treats the IT department and the HR department as 2 completely separate windows. See that rank in depth column? The second we get to the HR department with Ravi, bam, the counter resets to 1. This is exactly what we needed to solve our problem. Ranking is fantastic, but believe me, we are just scratching the surface. Window functions are like a whole new Swiss Army knife for your SQL queries. For instance, you can take normal aggregate functions like sum, AVG, or count and turn them into window functions just by adding that over clause. A classic example is making a running total. Imagine having daily sales data. You can easily add a column that shows the cumulative total for the month as each day goes by. So useful. But my personal favorites have to be lag and lead. I love this quote for them. They are the time travelers of SQL. Why? Because they let you reach out from the current row and grab data from other rows, either from the past or the future. Lag is like looking in your car's rearview mirror. For any row you're on, it lets you pull a value from the row that came before it. It's perfect for things like comparing this month's sales to last month's sales, right on the same line. And you probably guessed it, lead does the exact opposite. It's like looking ahead through the windshield. It pulls a value from the next row in the sequence. Great for forecasting or seeing what's coming up down the line. So this is all really cool, but let's talk about the real world. Why does this matter, and where are you actually going to use this stuff? The truth is, once you know them, you'll see them everywhere. They are the engine behind so much modern data analysis. finding the top-selling products in every single category, calculating month-over-month growth, building financial reports. Yup, window functions. Window functions, window functions. Okay, time to bring it all home. We have the tools, we have the knowledge. Let's finally solve that problem from the beginning, nice and easy. So the solution is really this elegant three-step dance. First, you write a query using row number 1 and partition by department to get that nice restarting rank. Step 2, and this is the trick, you have to treat that entire result as a temporary table, usually with something called a subquery or a CTE. Then, for step 3, you just write a simple select statement on the outside that filters for where your new rank is less than or equal to 2. That's it. Clean, powerful, and it works every time. Whew, that was a lot, I know. So if you're gonna walk away with just a few core ideas, let's make it these ones. Just remember, window functions add information without destroying your data. The over clause is the magic keyword that makes it happen. Partition by is your secret weapon for creating subgroups. You've got your 3 ranking functions for all your ordering needs. And lag and lead let you time travel through your rows. And I really can't stress this enough. That top n per group problem we just solved, it is without a doubt one of the most common types of questions you will get in a data-focused job interview. If you can master this one pattern, you are putting yourself in a fantastic position. So, you now have a key that unlocks a whole new level of analysis in SQL. The only real question left is, what are you going to solve with it first? Thanks for tuning in.